activity. So whatever is your vision, whatever you feel is the vision for your countries for NFCS, please send a small paragraph in email to Dr. Satyaban. Okay, because of lack of time, we cannot do that activity now. So we request all of you to send an email to Dr. Satyaban about whatever you are visioning for NFCS. So for this session, the session chair is Dr. Takemura and rapporteur is Dr. Sabir Ali. So I would like to hand over to Dr. Takemura.
Good afternoon, everyone. I'm Kazuto Takemura from JMA. I'm in charge of the session chair for the session 3, information on sub-seasonal products and their utilization. So the first presenter is Dr. Nana Seelan from IITM. Please share the presentation file.
Thank you. So good afternoon, everyone. So I'll be talking about the recent developments at our center on decadal prediction system development. And the outline of my talks are like this. I'll give a brief introduction of decadal climate prediction system because it's a new activity. Many of you may not be knowing exactly what is the system. So how well we can predict the climate few seasons or years in advance, because we are mostly talking about a seasonal outlook. So can we extend it beyond a season is the question, and how well the prediction beyond a season, and why do we need to predict climate a few years in advance? So those points also I will highlight, and some of the initial results of our decadal hindcast and forecast. I'll try to emphasize on the climate extremes over South Asia, because that is what mostly we have been discussing today. Near-term climate prediction is a term. It is used for the prediction of climate for the next few years. It's an interannual to decadal timescale prediction. The evolution of climate over few years to decades basically arise from the interactions of, how the climate system respond to the external forcing, mostly the anthropogenic and natural influences, and how it interacts within the system between the components atmosphere, ocean, land, surface or cryosphere, and then interaction between these externally forced and internally generated variables. So now if you look at the schematic of the sources of predictability and the ranges, you will see the familiar ones with weather, subseasonal and seasonal, and then you're also familiar with the climate projections. Now if you look at in between, there's a big gap from beyond a season and maybe up to a decade or so. So which is what is trying to fill by the near-term climate prediction or annual to decadal prediction. If you look at this, the challenges are, these annual to decadal variabilities are mostly controlled by the extratropical oceans, mostly the Pacific decadal variability and Atlantic multidecadal variability. And it's also partly influenced by the anthropogenic, natural and anthropogenic forcing. And also you can see there are some pathways from the tropospheric or stratospheric pathways. So So this is slightly tricky to model this annual to decadal time scale. And if you look at the predictability skill, the blue lines here are the initial value problems, the models which are initialized. So if you initialize a model, are the potential predictability coming from the initial conditions are having some impact for few years, but with time the impact reduces. But you can see the skill with significant skill is there up to 8 years or so. And if you look at the external forcing, the model, all the red lines are different models forced by the external forcing. And here all the models, different models with the initial conditions. You can see beyond some point or around 10 years, the externally forced model skill will improve, whereas up to a decade or so, the initial conditions will provide potential skill. So that is what we do in the decadal prediction, where you need to initialize your model with the observed ocean, cryosphere, and atmosphere. And similarly, you need to give the external forcing, which normally you provide for the climate projections. So now the operational decadal predictions, in fact, fill the important gap between the seasonal forecast and climate projections. So in 2017, WMO established the WMO Lead Center for Annual to Decadal Climate Predictions, so providing multi-model ensemble predictions covering the next 5 years. So this WMO Lead Center, they prepare the global annual to decadal climate update every May. So now you can see these are the centers participating in the global annual to decadal climate update. And recently, now this year onwards, the IITM also has been participating. So I will show you some of the results from the IITM model. So you can see these are some of the initial results, like the mod. And here one thing, we need to initialize the model every November. So this is like a mandate given by WMO. So all the models, all the participating centers have to initialize their model in November. So now here, for example, you see the skill of summer monsoon, this year monsoon. So which are normally initialized in February or March or April. But here we initialized it in the 2023 November. So that difference is there. Now the models initialized in 2023 and prediction for 2024. So this you can see different models for predictions for 2024 surface temperature. You can see different. The first one is the ensemble mean prediction, and these are prediction from different centers. You can see the IITM, the prediction also. So the right panels here, these are prediction for the next 5 years, like 24 to 28. You can see the most significant one. You can see this is like an ensemble mean is more reliable. You can see the entire northern hemisphere is going to be warm. The anomalously for the next 5 years. That is very clear, and it is consistent with most of the models. And you can see in the right side, you can see these are the prediction done using last year's initial condition for 2024, and these are the for precipitation, and these are for next 5 years forecast. These are prepared by WMO Lead Center at UK Met Office, and these are the prediction for this year's the El Nino or Nino 3.4. You can see consistently all the models are showing the La Nina. So here you can see these are shown by different models. All models are showing La Nina. So that's also very consistent. To give a brief introduction about our model, the IITM Decadal Climate Prediction System. So this is an Earth system model. So we in fact borrowed the Earth system model used for the climate climate projections. So we have taken a version which is very before the a preliminary version which participated in the IPCC AR6. So it's not the final version; it's a pre-version. We have modified that version to a decadal climate prediction system. So it's an Earth system model which has different components like ocean, sea ice, atmosphere, land, and and these models need to be initialized. And that too, the WMM mandate is that we need to initialize on every November, and we need to create at least 10 members. So our model satisfied all the conditions. So we have prepared the ocean initial conditions in-house, and the atmospheric initial conditions are prepared by NCMRWF from the NSUP ICs. So the members are generated by NCMRWF. So now if you look at this, the improvements we can see. So this is the mean JJS surface air temperature, and you can see this is the IITM Earth system model which participated in AR6. So this is the bias in surface temperature, and this is their pi control, and you can see the improvement what we have in the IITM, the climate decadal climate prediction system. So this is the improvement. For example, you can see in the major biases are in the the mid latitude in the northern hemisphere, so which has reduced a lot in our system, and in the polar region. See, this is a common problem with all the climate models: the mid latitude bias and the polar region bias, warm bias in all models. So which has reduced a lot in the climate system which we are using for decadal climate prediction. You can also see another improvement. It's the representation of the monsoon, this cycle, the seasonal cycle of monsoon. See, you can see the annual cycle is very much improved in this. The green one is the one which is participating in the decadal climate prediction. So these are the ones which are participating in the AR6. So you can see there's a lot of improvement, and we also seen how well the monsoon can be simulated. So that is why we looked at the relationship between the monsoon rainfall and different indices, and we found the model is able to capture the relationships very well comparable with the observations. And these are the North Atlantic oscillation. So shaded is the observation, and contours are model. I mean, you can see that it's very close correspondence, and you can also see the Atlantic multi-decadal oscillation, AMO. You can see this also captured by the model well. And here this is a heat map picture which gives you in detail skill of different models in capturing the variabilities at different time scale of monsoon rainfall or 3.4 PDO, AMO, etc. See, the bottom one is the observation. So you can see the scales are here, and these are observations, and the other rows are different models. IITM model is marked here. You can see compare the color bars with the observation. You can know that how good the models in representing the different variability of different periods. Like these are years. You can see the IITM model is able to capture the decadal and multi-decadal variabilities reasonably well. And this model has been used, and this is the sea surface temperature anomalies predicted for 2024. So from January to December, you can see the cold anomalies developing in the Equatorial Pacific. You can see from July onwards. So this is consistent with most of the model. So the model is actually predicting La Nina conditions this year. And you can also see there's another challenge in most of the climate models. The monsoon is very sensitive to Nino 3.4. So here you can see the observed relationship, these observed lead lag relationship of Nino 3.4 SST with the monsoon rainfall. You can see the simultaneous relation and lead lag. See, most of the climate models over-predict the ENSO monsoon relationship. That is a big challenge in climate modeling. You can see this model has improved a lot. I mean, this has a reasonably good representation of ENSO monsoon relationship. That's also a good improvement. And you can see this is the predicted rainfall for 2024 monsoon season. And you can see, we have seen that the SASCOF outlook also, like, it is closely matching with the consensus forecast with, some negative anomalies over the Gangetic plain and positive anomalies in the Western Ghat and Central Indian region. So this, this is like these are anomalies. And similarly, you can see the model predicted Tmax anomalies. This is for March, April anomalies, and the anomalies up to 3 degrees centigrade is marked here. You can see the warm conditions persisting over the entire region, May, June, and this is March to June. And we also looked at how good the model captured the rainfall extremes. So we looked at all the climate models participating in the decadal prediction, which are giving the daily outputs. So these are we could find only few models, and the top one is IITM model. And we looked at the skill in getting the extremes with the lead 1 year lead, how good. So you can see the skill scores are, So you can see with the lead 5, lead 10, and if you see with the different models like Easy Earth, I mean, that is one of the best model currently available. And this model is performing better than any other climate models contributing in this decadal prediction in capturing the rainfall extremes. So then with the bias correction, we have seen, this, if you see the observed and the model, we can see that, the skill in getting the rainfall extremes are very good. So these are the large area extremes captured in the last 40 years or so. You can see and the number of extreme days are also captured well. And this model now, we looked at how 2024 would be. In 2024, we are seeing, that there is an increase in the extremes. You can see, especially in July. So we don't know how good the model skill in capturing month-wise. We just looked at it, but we can see that, that July, possibly there are a lot of rainfall extremes over Central Indian region. And similarly, we looked at the medium area extremes. You can see these are the prediction for 2024. Again, July, August, there are going to be more extremes. So here, the large areas, it's like more than 70,000 kilometers square kilometer area, and medium, it's 40 to 70,000 square kilometer area. So similarly, the small area, also we see some extremes in the month of August. And we also looked at whether the heat waves can be captured. So these are the observations, and the model, and these are the prediction, 2024 predictions. You can see, there are, the large, these are for large area heat wave days. similarly medium area heat waves, and then small area heat waves. So these are captured by our model. And to summarize, the models initialized with the global observations and external forcing give reliable the prediction of the climate and its variability. And the warm spring summer conditions are forecasted for northern hemisphere, and it predicts La Nina conditions in 2024 from summer onwards. The more extreme precipitation and heat wave events are predicted for 2024. This is a, very early activity, and so in fact, I thank many people for this. IMD and SASCOF organizers, and Dr. Rupakumar Kohli, see who has initiated this, who has actually helped us bridging, us to come to this platform, and maybe from next year onwards, we can also prepare some products which may be useful for the SASCOF community. So mostly within the next 1 year, I'll be able to get the forecast in advance from other centers so that we can prepare a regional SASCOF decadal climate prediction products and maybe able to provide some useful information, at least for the next few years. So that is an activity which we can take up. So I think that will be very useful for useful addition to what the SASCOF community is doing. And also I thank the former secretary MOS and the director ATM who have initiated this program. And yeah, thank you. And any questions?
Any question or comments?
Yeah.
Thanks, Dr. Shindu. So I had one question. We know that given the chaotic nature of the atmosphere, for different initializations, you can get very different kind of outputs, especially if you're looking at things like extremes. And therefore, I'm wondering whether it might not be more useful, or probably one more additional useful product, maybe to look at return times of different levels of extremes, because that is a more statistical quantity. And we know from observations what is the return times. Let's say, okay, given the current climate state, what would be the return time for, let's say, a 10-year flood or a 100-year flood? How has it changed from observational means, or for extreme heat? So that may help for longer term planning and adaptation.
Exactly. Yeah, you're right. So I did not show much of the long-term things. Normally in the decadal prediction community, they look at the next 1 year and then next 2 to 5 years. See, that is where, as you said, so the long-term, like in 5-year time. So what are the possibilities of occurring more extremes or more anomalies? So that is what they do. Or 2 to 9 years. See, in the next, what is the weather, what is the climate for the next 10 years or so? So what are the changes? Because, and one more important point, see, the prediction skill diagram I have showed you, it's very important. See, if you look at the next 10 years or 30 years, normally, we had discussion saying that the climate model projected some extreme conditions for the 30 years. There is a lot of uncertainties in the near-term climate projections. See, that is how the importance of decadal climate prediction system came. Because the initial period of the climate also depends on the initial conditions, which are not considered in the climate projections. So those near-term climate projections uncertainties can be addressed with this.
Yeah, Dr. Jnanashila, actually, a very good effort, actually, having a decadal prediction.
But then I was expecting that no, what you presented is a just kind of another seasonal prediction model.
Correct.
type. At least I expected to have all the season forecast of 2024, which would have given us not only monsoon season, how it will be northeast monsoon entire 1 year, what will be the temperature even globally also, and at least 2-3 how that performs, and then we would have seen that whether La Nina how it ends, like that. So it is just like what
Correct.
you have
Yeah,
presented is
I understand. I
typical
understand
seasonal
that.
forecast.
Yeah, I understand that. Yeah. So, yeah, so we got very little time to prepare for this. So, because we just now participated in the decadal climate prediction, and then when the SASCOF invitation came, we did not have much time to prepare and make a comprehensive presentation. As you said, I take this point very positively. If we are asked to present next year, so you may get all those details. Yeah, but some of the WMO provides the outlook only in May. So because for that all member models are also required. So unless with only one model and 10 members, we cannot say it very confidently. So the next year, definitely before the next SASCOF, we will try to get because now some centers have asked us that our data for their regional forecast. So now we are building a bridge. So we will also try to get their data. So maybe by the next year, so we will be able to get more forecast from different centers and then use them and make a comprehensive regional outlook.
Congratulations, Shilan, for this excellent work. And in fact, I think we are now achieved this landmark capability in decadal prediction and also making it operational. I hope you will be able to also go for the WMO Global Producing Center for Annual to Decadal Climate Prediction, which is actually a more sustainable responsibility. In fact, the Global Annual to Decadal Climate Update that you have mentioned, the current version actually is in the draft form. I just received a draft for review. You also might have received it. I think going a step further, see this update contains both monitoring information, that is the past 5 years, and future 5 years. If we can actually build on that and to provide an annual to decadal climate update for South Asia, bringing more detailed information about South Asia, I think that will be of great value for the region. So that's one aspect that probably you can. And I also would strongly recommend including the decadal update as a standard part of SASCOF every year. I think that's very helpful. And one final point I would like to make is about dynamical downscaling of your global model output. If there is a possibility, I don't know the skills available for dynamical.
It is not available. It is not available. I asked other centers also. So very few centers have dynamic downscaling. But I proposed in the WMO meeting, but they said it is very difficult because we have a 10 years forecast and then 10 members. And then you go for, even if you go for 25 kilometer, that is going to create huge data sets. So maybe in future we can think about, because we need a good server or like IATM supporting codecs. Similar thing we have to plan. But yeah, maybe, we thought first we'll demonstrate it. So we'll improve the skill. So we demonstrate it completely and then think about the dynamic downscaling. Yeah. So thank you very much for all your comments, and not only for this and your support throughout this activity. And you are one of the motivator for this. And all these suggestions which you gave will work for that. Yeah.
Thank you.
Thank you
for your presentation. The next presenter is Dr. Johnny
from IMD.
Before starting presentation, I have one announcement. There is one vehicle numbered as MH11BL1881. So we require its key because its parking has been done slightly at different place. So I repeat number MH11BL1881. Okay, thank you. You may start.
Good evening, everyone. I'll be presenting on the IMD's operational extended range forecast system. So this is a schematic diagram of operational extended range forecast system in IMD. IMD is running the extended range forecast using the pseudo models CFS version 2 and GFS, and with at a two different resolution 382 and 126. Each suite of combination using 4 members, consisting of total 16 ensemble members. And we are issuing running the model on the every Wednesday's initial condition, and forecasts are generated for the 32 days. Atmospheric ICs we are getting from the NCMRWF, and ocean ICs we are getting from the INCOIS GOTA system. And we are using the hindcast of 16 years from 2003 to 2018. And ensemble mean products are generated for the weekly mean ensemble mean products are generated for valid for every Friday to next Thursday, generated for 4 weeks. And in this talk, I will be discussing mostly over the verification of whatever the products we are generating for the Indian region, and what are the products currently we are generating from the ERF for the South Asian region. So this is the last monsoon daily mean rainfall over the different over the all India region and Central India region. Here we can see that a weak monsoon over the June, and then active July, and again a week August, and then active September. This intra-seasonal variability is able to predict by the our model. So this is a 850 HPA wind and wind anomaly. From this wind plots also we can see that monsoon onset was also 1 week delayed, and the first half of the June it was weak. This can be seen from this wind pattern. This is an initial year of forecast based on the 17th May initial condition. And this is the rainfall forecast based on the 17th May initial condition. Here also we can see that week June month end, then onset delayed over Kerala. This can be seen from the figures. And this is the observed anomaly for the June month for the different weeks in the left hand side. And this is the similar issued for the forecast issued for the 31st May and 7th June. There may not be a one-to-one match, but still model is able to predict the forecast pattern. And this is the similar plot for the July. Active July. Here also the signature of the active July can be seen in the model for 4 week forecast based on the 28th June. And this is a similar plot for the August. And September also, our withdrawal of the monsoon is also delayed by 1 week. And here are the extended range forecast issued for the based on the 30th initial August initial condition and 6th September initial condition. This signature of the delayed withdrawal can be seen from this. Also. This is the withdrawal map of the monsoon withdrawal, which shows the starting on the 25 September. And now we are discussing about the forecast scale of the ERF over the smaller domain. So here that it is a weekly rainfall departure valid for the different weeks, and shown in the model forecast for the 4 weeks shown in the bar chart, and line plot shows the similar plot for the observed departure. So model is able to predict the pattern. And here you can see the correlation also. So up to 2 weeks, it having good correlation. If week 3 and week 4, the correlation is less. And this is the similar plot for over the central India and South Peninsula. Here also we can see the up to 2 weeks, good correlation is there. And this is a similar plot for the Northwest India and Northeast India. So Northwest India, week 1 it was good correlation, but week 2 onwards correlation is less. And Northeast also up to week 1 and week 2, good correlation is there. And this is the correlation coefficient between the forecast anomaly and observed anomaly for the subdivision wise. Around 36 subdivisions are there for India. Here we can see that week 1 there is a good correlation, but week 2 also slightly less, and week 3, week 4 coming down. For correlation is going between the forecast anomaly and observation anomaly is coming down. Now, actually, we are using a categorical verification that whether over the whether rainfall departure is coming in the range minus 19 to plus 19 is considered as normal, and minus 20 to minus 59 is considered as below normal, and plus 22 greater than 20 it is we are considered as above normal. 3 category rainfall verification we are doing. So this is the how much that observation model predicted, and category that model predicted is excess and observed is excess. So how much percentage is a category matching is correct. So week 1 it is good, and week 2 coming down, and week 4 the correct category matching is coming down. And here it is a wrong category matching, that is excess become below normal, or below normal become excess. So in that cases, week 1 it is, all that weeks it is very less cases only that excess become below normal, 2 category jump it is happening. And this is it is represented in the table. So we can see that a wrong category matching, correct category matching is happening in the week 1 in 62, week 2 in 45%, week 3 in 40, week 4 in 29%. But wrong category matching is week 1 is 9%, even week 2, week 3 also it is coming in 15% only. Although ERF has a good skill in 2 to 3 weeks, there are many occasions that the skill is limited to 1 week only. This is an heavy rainfall occurred over the North India during 8 to 13th July. And here is the forecast. So based on the 5th July and based on the 28th June. So 5th July model is able to predict the above normal rainfall over the region. But at 28 June, it was not able to. So week 1 model was able to predict, week 2 was not able to predict. So lead time of this event was small. And this is another event of the 16 to 19 December over the southern part of the Tamil Nadu. Heavy rainfall occurred in 17, 18, 19. And this is the similar week 1 forecast valued for the 15 to 21 December. One is the actual and one is the anomaly. Here, large excess rainfall is forecasted by model. This is for the week 1 and week 2. Week 2 also, both it were able to predict the excess rainfall. And this is the temperature Tmax for the last June 2023. So we can see that Tmax anomaly, positive anomaly can be seen over the many part of the region. And this is the forecast anomaly for based on the 2 different initial conditions. So the Tmax anomaly here also model is able to forecast the Tmax anomaly. Now these are the verification of the products whatever we are generating for the Indian region. Now what are the products currently we are generating over the south, covering over the entire South Asia region? One is the cumulative rainfall for the different weeks. For the weekly cumulative rainfall for the week 1 to week 4, and we are generating an anomaly also generating, and 850 HPA wind at 850 HPA anomaly, and wind at 200 HPA, 500 HPA and anomaly we are generating. And this is another product we are generating use the cyclogenesis probability. So this is for the during the cyclone Mocha that is moved across the Bangladesh and Myanmar coast. So this also 2 weeks before we were able to predict the probability of cyclogenesis. And this is for the another product we are Tmax and Tmax anomaly and Tmin and Tmin anomaly we are generating for the over the South Asian region. So summary of the forecast of wind, rainfall, temperature, cyclogenesis potential are being generated at different spatial and temporal scale. And ERF has a good potential for application in various sectors with a useful skill up to 2 to 3 weeks. Different customized products, ERF products are generated for the different sectors, agriculture, water, power, health, and other things. We are generating the subdivision wise and a district forecast also using the extended range. So the real-time ERF data we are sharing with the various users and countries for preparing the customized products. Thank you.
Thank you for your presentation. Any comment or question? You showed the each week forecast, each week 1, 2, 3, 4 week forecast
Yes.
for the precipitation. But in 3 or 4 week prediction, the prediction skill is very
less.
limited.
Yes, less.
In JMA has the same problem for the low predictability for the 3 and 4 week forecast. So JMA forecasts the average of the 3 and 4 week forecast. Okay, not each week forecast of 3 and 4 week forecast, but also the 3 and 4 averaged forecast in JMA perform. So I expect that I expect that the average of the 3 and 4 weeks has obtained the more higher prediction skill, I think. Okay. So because uncertainty of the intra-seasonal oscillation, such as BSISO and MJO, is larger in the 3 and 4 weeks.
Okay.
That's it. It is my comment.
So you have 4 weeks of forecast. So did you get chance to or coordinate it with the countries to verify how your model is performing in various countries of South Asia, or it is just for Indian region?
We have carried out a verification over the Indian region only.
So if now we have a few countries here, so if the SASCOF countries wants to have to verify how the this model output is doing, then how can we do it, like in a country?
So we can provide the forecast.
The digital data?
Yes.
Okay. And the verification methodology as well? And
Yes.
okay, thank you.
Okay. Thank you for your presentation. The next presenter is sorry, Dr. Misra.
Good afternoon. Thank you very much, SASCOF, and especially Dr. Srijit to invite us and present NCMRW of modeling products, especially at seasonal and sub-seasonal scale. This is a center which is located in Noida, New Delhi, near Delhi, and this is a center of excellence in weather and climate modeling. Started sometimes in 1988-89 for especially for the modeling purposes, and this center was the one which started using supercomputing facility for weather and modeling. And this was what picture you are seeing is here. Then Prime Minister dedicating the supercomputer to the nation on the right side, and this is the same computer kept at our center, especially for students and for exhibition purposes. And there are many people here. You can see that Dr. Narayanan, who became president later, and Dr. Datta, many senior people probably would recognize other members as well. So this center started as a modeling center to underpin the IMD modeling activities, and we try to support modeling and forecasting exercise of NDMA department. As of now, we are using seamless prediction system, which is based on UK Met Office. And as you can see, we are doing across the range. We are doing global model at 12-kilometer resolution. We are also running a regional model at over India at 4-kilometer resolution. We are running 330-meter Delhi model, which deals with the urban mythology and fog forecasting, especially during winter season. We do 1.5-kilometer regional model forecast for specific for like Amarnath Yatra and something any special event. We have 23-member ensemble prediction system, which is at one point of time highest in the world. And we also have a couple modeling system, which is based on coupling atmospheric model of Met Office with the NEMO and JULES and sea ice model. So if I just try to summarize here, basically we have uncoupled models, versions of the model at global at 12 kilometer, which is, and then ensemble prediction system producing 23-member ensemble at 12 kilometer and regional at 4 kilometer. What I am going to present here, which is going to deal the S2S predictions forecast from the global coupled model, which is running at 60 kilometer atmosphere and 25 kilometer ocean. And we're also having experimental regional coupled model, which will be run at 4 kilometer atmosphere and 2.2 kilometer ocean with waves and other components as well. So this is, to summarize, we are running these coupled model at 60 kilometer with NCOM unified model atmosphere, Joules as a land surface model, NEMO as ocean, and CIS model as a CIS component. And we are running every day, daily, this model at a medium range forecast, 15 days forecast. And then extended range is run every week, every Thursday. And seasonal is run once in a month, end of the month. And this especially medium range is using this product is basically using 60 kilometer atmosphere and 25 kilometer ocean. So ocean products, especially TCHP and other applications, we are using this particular product. Extended range, as earlier speaker has explained, we are running every Thursday. We are issuing forecast every Thursday, and with 16 ensemble member, Sunday starting from Sunday to Wednesday. Similarly, seasonal prediction is done with the 55 ensemble member, and each month from 12th to 22nd, we try to we run this model every day with the 5 member and with time lag. And total, these all seasonal and some extended range has used 23 years hindcast from 1993 to 2015. When we started this coupled model 2018, we also tried to do the coupled 10 kilometer coupled version also. At that time, an operational model, which still is actually 12 kilometer atmospheric model itself. And we have seen that this preliminary results has shown that 10 kilometer coupled model has a very nice scale, and it is improving the, it is reducing the biases and improving the skills. But at that point in time, the NWP at coupled resolution was not at all required. At emergency, it was not mandate at that point of time. We are now working to develop with the latest version of the model. So we, 2017, we started 15 days forecast every day. 2018, we started this extended range forecast. What we did, every Sunday we are running this model as graphically it is explained here. Every Sunday we are running 4 models by perturbing the initial condition using stochastic physics. And similarly, Monday, Tuesday, and Wednesday, and Thursday the forecast is issued. Most of you may be receiving this email from us, and data is also shared with the Sri Lanka and Myanmar and some other countries on the request. So this data is also communicated. Plots are also shared with the IMD and other MOES sister agencies, and on request it is available to research organization as well. So this is using 7-member hindcast to calculate anomalies. Forecast is using 16 members, as I explained here. And you are just showing one sample that this is weekly forecast verification. This one is showing observation. As you can clearly see that this dry bias, yellow color is by the way dry bias. These are showing the rainfall anomalies for this period, 9 to 15 July. You can clearly see this signal was captured even the week 3 or even a little bit in the week 4 as well. Similarly, this dry spell was very nicely captured even up to week 4. These are just 2 examples. We'll show some more examples. So this is, if we do the hindcast, analyze the hindcast 23 or hindcast, this is observed mean for June, July, August, September, 1998 to 2015. And this is model hindcast for the same period. And as you can see, the biases in the week 1, week 2, week 3, week 4, how they are developing over, especially Western Ghats. We have dry biases, and as the week advances, as the length of the forecast advances, it is spreading over the inland areas. These are some verification, just randomly picked. You can see the week, this is observed. These are week 1, week 2, week 3 forecast. Similarly, this is the period mentioned here for the July 2022. This is observed, and you can clearly see the yellow color is basically showing the below normal, and the blue color is showing above normal precipitation. You can clearly see the dry spell over this dry area is nicely picked up even week 3. Same way in the month of September, this dry bias was seen even the week 3, and this wet signals over this area is very nicely picked up even week 3. So this model has a very nice potential to capture signals, especially up to week 3 and week 4 at some time. So this is one comparison we did for a particular time in 2018, one case study, which top panel you see the observations from 12 July and then up to 1st of August, week 1, week 2, week 3. This one is multi-model ensemble mean. This one is NCMRW of week 1, week 2, week 3 forecast, and the bottom one is IMD CFS. As you can see, this observation clearly shows the dry over the Bay of Bengal and the active rainfall over the Indo-Gangetic plains, and central and peninsular over India. There is a wet signal, a dry signal, which was not the case in the IMD CFS here. It was completely reversed, but NCMRW model had this signal. And if we do the ensemble mean, then the signals are very nicely captured. So that gave an idea that multimodal mean can be of great use, especially at this time scale. This is a sample forecast which we issued last Thursday. It will be updated tomorrow and will be shared with all the mailing list people. Anybody wants, they can write us. This is precipitation forecast. We recently extended the domain. Earlier, domain used to be smaller. On the request of some users, we extended the domain. And this is precipitation. This is anomaly forecast. As you can see, by week 4, which is going to be around ending 23rd May, you can clearly see the onset chances of onset monsoon, and it's very likely there. And this is again temperature, showing minimum temperature, actual full field, and this shows the anomaly. And as I say, this last week we had WD activities, which is keeping the minimum temperature below normal. And slowly the warming is picking up in the week 3 and week 4. Similarly, maximum temperature, full field, and anomalies again are showing that warming trends are, especially in the peninsular India, which we are also experiencing here, is going to continue for another 2 to 3 weeks. We are also producing the CIS product, because this model has a CIS model. So we are also sharing this CIS product with the NCPR and any other agency which is interested in it. And you can clearly see the based on 25th April initial condition, notification forecast, next 4-week forecast on the both north and south pole shows the anomaly forecast of CIS concentration. We also regularly produce sea surface temperature, sea surface mixed layer depth anomalies, and sea surface currents, sea surface heights, and many other ocean products which are actually hosted at our website. Please feel free to explore that. This is one experimental product which we are still working to develop. This is a SPI drought index based on our 1-month forecast, and this actually uses rainfall and some hindcast climatology, and based on that, this product is still under development. And we found some interesting, encouraging remarks and encouraging buyers from, especially from the research community. And now coming to the seasonal forecast system, as this seamless prediction system is also used for the days to season forecasting. So we started 2019 onward, we started seasonal forecast every month. And as I said earlier, again, this is 60-kilometer atmospheric model, 25-kilometer ocean. And hindcasts are run for the same period, and 55 member ensembles are used. And this is one sample forecast, initial condition May 2022. This is what the actual rainfall field. This tells the anomalies, and this is actually tercile probability forecast. We're also issuing the forecast of snow, especially to the DRDO agencies and any other agency which is requesting this. And as I can tell that snow forecasts are very, very good quality, because it has been confirmed in the last season also. Our model has captured the below normal snow forecast. This is just showing the the climatology, hindcast climatology of our model, Met Office model, which is NCMRW model as well, and comparing with the ECMWF model. This is basically model climatology. This is observed climatology. Both are same plot, and this shows the biases. How we are almost comparable with the ECMWF climatology. And then when we started in 2018, when we started running model, the first case we ran in the May 2018. And this table was provided by IMD at that point of time. This is the skill of IMD model, very nice skill actually at that point of time, but we are also comparable with the IMD CFS system, seasonal forecast system. So now we are actually trying to further improve this model. This model has a very interesting, like any other model. Sometimes the ENSO and IOD indices, you can see the blue colors are forecast, black one is the observation, and the plume is shown in this the shade. You can see that Nino 3.4, as you can see, most of the months, most of the initial conditions, especially last year, ENSO was overpredicted. Whereas DMI, Indian Ocean Dipole, especially in the month of April and May, was overpredicted by model. So what what happened because of that, especially if you see once again, this is the April initial condition, Nino, you can see very strong Nino was predicted by model. Whereas the Indian Ocean Dipole was also there, showing very high Indian Ocean Dipole. So what happened because of the model forecasting reduced rainfall? This was by the way our forecast, and this actually happened. So this green color is above normal, red is below normal. So our forecast was going to be below normal, but it happened because of the strong ENSO in forecast. Model was realizing that it is going to be below normal rain, but actually it was not that strong, and that resulted in this kind of actual realization. In the May initial condition, if you see once again, this ENSO, ENSO was present, but strong IOD was forecasted. But June, July, August IOD was much weaker than strong ENSO, resulted in reduced rainfall. So this happened. All the forecast was near normal, but because of this strong ENSO, this resulted in this kind of progress. So this is a paper by Ankur in climate dynamics, which says that Indian Ocean dipole dynamics is underpredicted, presented in model 20-30 years back. I think that was the case with the ENSO as well. So El Nino is now better realized in the model. And if I show you the recent this month's forecast, last month's forecast, and this is what we have using the April initial conditions, May, June, July rainfall prediction, and this is June, July, August, September rainfall prediction, which is almost above normal, almost every part of the country. And this is a precipitation anomaly forecast for the same May, June, July, and this shows you month by month, progress month by month anomalies, especially May, June, July, and this shows you June, July, August, September. And it shows more or less distribution, spatial distribution of the rainfall during these months. This shows you whole tropical view, temperature forecast, especially over the Indian continent. And this is the forecast for El Nino and Indian Ocean dipole. You can clearly see dipole is Indian Ocean strong, positive dipole is seen here. Nino, La Nina is seen, evolving, but whether it will realize or not, that is still to be watched. These are the forecasts. As I see, Nino 3.4 index are clearly indicating that Nino is La Nina is going to probability of being La Nina is very high here, and especially similarly Indian Ocean dipole probability is very high, especially positive IOD. But I don't know whether it will be realizing or not. But coming to the concluding these things, if you see our extended range forecast has a very, very high skill, especially as Johnny has shown in earlier presentation, up to week 2. But week 3 onwards, the skills, especially over all India regions and subdivisional levels, are not very good. But as you see, these are very well in agreement with the different initial condition. You can clearly see the black one is observed, and different initial condition hindcast forecast is shown here. But the dispersion is very less. They are under dispersive. Models are very, very under dispersive. But if we see over the different homogeneous region, especially monthly skills, there you can clearly see that monthly skills are far better than these kind of things. Especially if we see the impact of spatial averaging over the monthly mean skills, you can clearly see that skills over homogeneous region is far better compared to the subdivisional and the national level. As you can see, this clearly shows, especially this green color is June, July, August scale, JJS, June, July, August, September, and these are monthly skills. You can clearly see the skills are, all India skills are far ahead, and 0.6, 0.7 is this 0.6 up to 0.6 skill is seen in the northwestern part of the country, which is far more than the subdivisional scale. We are also developing some products based on, temperature and humidity. This is heat index, since the morning session was very much focused on the heat index. So this is right now at a medium range time scale, but we are soon going to develop this product as an extended range forecast, extended range scale as well. And this probably we are still testing this with the caution that people should follow the IMD advisory, not the model guidance which are presented here. And these are based on NOAA methodology. They have an empirical relationship based on several indexes and some empirical relationship between temperature, humidity, human comfort, and many other things. And these products are available on our website, and anybody can go and see. Many other products we can clearly go and see, especially in the model guidance and special product section. And digital data is also available for your any application you want to develop, any other research you want to do. My request to IMD and other users here, please feel free to use this data. Please feel free to contact us if you want to use this data. We are also trying to dynamically downscale our extended range forecast from 60 kilometer to 4 kilometer. We are trying to see how much this data is going to be useful. We are trying to evaluate the skill of this product. I'm hoping that this product, especially at the medium range time scale, it's very nice. Skills are very good. So we are hoping this at extended range, especially monthly and week 1 to week 4, we'll have a very good skill forecast. Thank you very much. If there is any question, I'll be happy to answer.
Thank you for your presentation. Any question or comments? Ah.
I have 100 slides. I can show you if you have time. No, it was randomly picked. It's not selected. And if you want, I can share, because all these verification plots are shared with everybody in IMD. Yeah. Yes, I understand. Yes. Yes, I agree with you, but yes. Certainly, all models across the scale needs improvement. I agree. Thank you, sir. Thank you. Yes, Jose.
Thanks, Dr. Mishra.
Yeah.
So I had two questions. One was regarding this heat index predictions. I mean, almost all models have major problems predicting things very close to the surface. And especially for heat stress, it tends to be very sensitive to even slight changes in humidity. The heat index itself is not very sensitive, but there are other heat stress indices which are very sensitive. So has there been any verification, validation of near surface predictions of, let's say, T2M, Q2M, and how good they are? So that is one. Then the second thing, you were talking about dynamical downscaling. Clearly, since at that scale, the chaotic nature of the atmosphere is going to dominate, is there a plan to make that also sort of an ensemble prediction? Because just doing one downscaling is not going to.
Thank you for your question, Ross. I think you're right. Temperatures, especially near surface, are a problem. And it depends. Certain time of the year they are okay, but certain time of the year they are not okay. But we got this, special request to create this product, and it was from ministry. This request came, and it was very quickly they wanted. So we thought of following the NOAA's, well-established, that criteria, and we implemented that. But certainly, I agree with you. We need to go and validate, especially a couple of seasons we have to forecast and see not only just this product, also the temperature and humidity as well, because both products has the problem. Both products have problem. Obviously, the maybe the one product problem might be addressing the other products issues. So sometimes, you never know. So you ended up with better forecast. But we need to look into the details. Yes, certainly. Your second question was about the dynamical downscaling. Yes, we want to do, we have 55 member ensemble. We want to do all. But unfortunately, the supercomputing facility and storage condition is not supporting that. We are, as of now, we are going ahead with one model, deterministic model. But as we see any encouraging results, we will certainly, request ministry to provide us more computational resources and storage, and certainly ministry will support. So that we'll have to produce that. It is very useful. So we'll have to show that, demonstrate that. Thank you.
Thank you for your presentation.
Thank you very much.
Okay. The next presenter is Dr. Rohini from IMD.
Good afternoon to all. I'm going to present the verification of heatwave outlook for hot weather season 2023 issued by IMD. Before going to the heatwave verification, I will give an overview of heatwave over the Indian region. We all are talking very seriously about the climate change, global warming, and all over the last few decades. And we know the surface temperature is one of the best indicator of climate change. And according to the recent IPCC report, the global mean surface temperature shows an increasing trend of 1.1 degrees Celsius over the period 1880 to 2022. And climate change, and we know the climate change manifests in the form of increasing extreme weather events. And these are some extreme weather events which were rare in the previous climate and is very often in the present day warming scenario. And we can see how that change in temperature leads to the change in extreme weather events from this figure. This figure is the probability density function of temperature, and we know this is the normal distribution, and the center is the center of the probability density function is mean, and shape gives the variance. And this is the this figure. Suppose the first curve is the previous climate, and suppose the mean is increasing. That means the normal distribution itself is shifting towards the hotter region. Then we can see we are going to experience more hot extreme weather events and less cold extreme weather events. Suppose the variance is increasing, then we are going to experience both the cold extremes and hot extreme weather events. And in case of increasing both mean and variance, then also we are going to experience more hot extreme weather events. That means increase in mean or variance or both of the temperature leads to the increasing in the probability of hot extreme weather events. And heat wave is one of such hot extreme weather events. And we are in Indian region, we are experiencing these very often nowadays. And we are going to the heat wave definition. And heat wave is just nothing, a period of above normal temperature. And depending on the geography and the climatic condition, the definition of heat wave is varying. And WMO defines the heat wave when the daily maximum temperature exceeds the average temperature by 5 degrees Celsius for 5 consecutive days. But we know India is a vast country with a various geography and the climatic conditions, so that IMD is using a different criteria for declaring the heat wave. The IMD criteria is based on departure from normal as well as the actual temperature. But based on the actual temperature, we are declaring heat wave only over the plain regions. And the criteria is if the maximum temperature of a station reaches 40 degrees Celsius or more in the plain region, and 37 degrees Celsius or more in the coastal region, or at least 30 degrees Celsius or more in the hilly region. Then if the departure from normal is 4.5 to 6.4, we will declare it as a heat wave. Or if the departure is greater than 6.4, we will declare it as a severe heat wave. While considering the actual maximum temperature over the plain regions, if it is greater than 45 degrees Celsius, we will consider it as a heat wave, or if it is greater than 47 degrees Celsius, we will consider it as a severe heat wave days. For declaring the heat wave, the criteria should reach at least met at 2 stations in a subdivision for 2 consecutive days. Then IMD will declare this on second day. And in Indian region, we are experiencing heat wave during March to June period. And this is and we can express the heat wave in terms of frequency. Frequency is nothing, the number of events occurred in a season. And we can express in terms of duration. Duration is the how long a heat wave persists. And also in the intensity. Intensity is the maximum temperature observed in that particular spell. This is the analysis based on IMD criteria, and for this analysis we have used the 103 IMD stations, T maximum temperature data, and this figure is climatology of heat wave frequency and duration for the period 1961 to 2021. And we can see on an average, the left panel is the heat wave frequency, and we can see on an average 2 heat wave events occur over the country, and in some isolated pockets it is exceeding 4 in a season. And coming to the heat wave duration, that is the right panel, and we can see the heat wave persist on an average 4 to 8 days over the country. And some pockets in central northwest India and parts of Odisha and coastal Andhra Pradesh, duration exceeds 8 days. And we have conducted the trend analysis for the same period, 1961 to 2021, for the heat wave frequency as well as for heat wave duration. We can see almost all stations showing the increasing trend except the foothills of Himalaya and some eastern part of India. And duration also showing the same trend. But IMD's definition is for based on the station temperature data. Then we cannot use the same criteria for the gridded temperature data, so that we have tuned the criteria based on the percentile for the gridded temperature data and for the Indian region. And the criteria is that when the daily maximum temperature is greater than the daily climatological 90th percentile, and the climatological daily maximum temperature is greater than 35 degrees Celsius for consecutive 3 days, we will treat it as a heat wave. And percentile is calculated based on 5-day window, and for calculate the reference period used to, for the coming analysis is 1971 to 2000. And we have repeated the same climatology and the trend with IMD gridded temperature data for the period 1961 to 2021 and for the season March to June. And we can see we are also getting on an average 1 to 2 heat waves over the country, and heat waves is more over the central and northwest as well as the coastal Andhra Pradesh and Odisha. And heat wave frequency, heat wave duration is also 6 to 8 days over the country. And heat wave intensity, we consider the intensity is the maximum temperature occurred in a spell, and we can see the heat wave intensity is going more than 44 degrees Celsius in the northern part of the country, and it is around 40 degrees Celsius in the coastal Andhra Pradesh and all. And this is almost similar to the analysis by the IMD criteria and the station temperature. And the trend analysis also we have carried out, and we can see the significant trend is over the northwest, central and east coast of Indian region, both the frequency and heat wave duration. And this is similar to the IMD station temperature data, and we can see the decreasing trend over the foothills of Himalayan region and eastern part of India. And the heat wave trend analysis of heat wave intensity showing the increasing trend over the northern part of the country, and the intensity is decreasing in the coastal Andhra Pradesh and all. And this is the climatology based on both criteria and the heat wave over the Indian region and all. Now we are moving to the heat wave outlook. IMD started issuing the MME based heat wave duration anomaly since last year. And for this, we need the daily maximum temperature, and these 8 NWP centers are providing the daily maximum temperature data set, so that we are using this model output for making this MME forecast, and we are using the percentile criteria. The only which I have already explained. The only difference is for computing the climatology, we are using 1993 to 2016 because the data is daily data is available only for this period. And we are using the climate model output after the Z bias correction using the IMD grid temperature data. And IMD is issuing the anomaly heat wave duration forecast for MAM March, April, May, and AMJ April to June season, as well as monthly. And this is the maximum temperature forecast skill for MAM season based on February IC, and we can see the maximum temperature. The skill is a very good skill is showing, except NSUP model, and the right panel showing the heat wave duration forecast. Heat wave duration showing the reasonable skill in almost all models. And this is the computed climatology of heat wave duration for the MAM season for individual models, as well as from the observation. And we can see the most of the model are underestimating the heat wave duration. And this is the skill of MME for the MAM season, and based on the February IC, and it is showing very good skill over the country. And this is the heat wave duration climatology. Then this is the observed as well as the issued heat wave forecast for the season MAM. And we can see we have experienced normal to above normal heat wave duration over Bihar, West Bengal, Odisha, and some part of East UP, Rajasthan, and Saurashtra and Kutch. And below normal, rest of the country experienced the below normal temperature. And our prediction was also correct. The above normal are predicted over this region, and below normal was also predicted well. And coming to AMJ season, the maximum temperature forecast is good. The skill is very good for maximum temperature, and the duration is also showing some reasonable skill in almost all models. And this is the climatology of heat wave duration for AMJ season. And here also we can see the models are underestimating heat wave duration. And this is the MME skill and heat wave duration climatology. The skill is, we can see the very good skill over the country. And the heat wave, this is a heat wave climatology. On an average, 4 to 7 heat waves are observed during MAM season. AMJ season. And this is the observed heat wave duration during the AMJ season and the forecast as well. Here we can see the normal to above normal heat wave days were observed over the East India, East Central India, and the east coast of Southern Peninsular India, and some part of Northwest India and West Central India. And we have we have issued the above normal forecast over this region, but the model we have issued the above normal forecast over the Northwest India, some part of Northwest India as well, but it was not coming. We haven't received any heat wave over that region. And now we are moving to the monthly forecast. There was no observed and predicted heat wave during the month of March, and the prediction was correct. And coming to the month of April, we experienced above normal heat wave over some part of East UP, Odisha, West Bengal, and Bihar. And we have predicted the above normal heat wave over this region. And rest of the country has not experienced any heat wave events, but we predicted the above normal heat wave in the West Central India also. And in the month of May, the May prediction was not that good. We have experienced heat wave in very few areas in very few areas in the west central India and some part of east India. But we have predicted above normal temperature in the Gujarat region and all. But the southern part of India also, southern peninsular India also, we have predicted above normal heat wave, but there was no heat wave experienced over that region. And coming to the June month, that was last year we experienced the more heat wave during the June month, and the very above normal heat wave in the eastern part of India. We can see the coastal part as well as the East UP, Bihar, West Bengal, that all that region. And we have given the above normal forecast for that region also. But the forecast has above normal forecast has given for the northwest, some part of northwest India also, but we haven't experienced any heat wave over that region. Overall, our heat wave forecast was reasonable, and so that the end users can use this to take the necessary action for that region. And what are the challenges to make the heat wave outlook for South Asian country? Actually, the existing index is developed only for the Indian region, but this will work for the Pakistan region. And this is some analysis we have made based on the 2022 heat wave, which was affected in the Pakistan as well as the northwestern part of India, and it is getting very well. So that this criteria is useful for Pakistan region. But other countries, this may have some problem for the other countries. And also, there is an inadequacy in the observed daily maximum and minimum temperature data, and the long-term records of the heat waves from the other countries are not available, and so that we don't know what happening over that region. And also the lack of information of the criteria what they are using for providing the heat wave forecast, that also not available. So that these are the challenges to provide the heat wave outlook for the South Asian countries. For understanding the more on heat waves over the Indian region, you can refer the monograph published by IMD. That's it. Thank you.
Thank you for your presentation. There is no time behind the schedule, so short one comment or question. Any question?
Hello, you have shown there is a decreasing trend in heat wave numbers in the eastern region, nearly in West Bengal and Odisha. But at the same time, the recent years, you have also shown there is decreasing trend in the heat waves.
No, decreasing trend in the heat wave intensity. Heat wave intensity.
Heat wave intensity. But at the same time, there is an warming trend in the same region in the recent years. So,
yeah, actually, we are. What happened is we are computing the heat wave intensity as when in a particular spell, what was the maximum temperature observed that we have taken. Then it is showing the decreasing trend, but definitely the temperature trend is increasing.
okay. Thank you.
Thank you for your presentation. The next presenter is Dr. Joseph.
Hello everyone. So today already There were some presentations on the subseasonal or the extended range predictions. So I will be talking on our journey in extended range prediction at IITM since the inception of monsoon mission and also the recent developments. So this is just an outline that in the subseasonal scale or the extended range time scale. So basically what we see is that the forecast skill is comparatively less considering the weather forecast and the seasonal outlooks. And here our interest is mainly more than 10 days and up to 30 days. And we generally give the forecast as the weekly averages. And basically the predictability is coming from the initial atmospheric conditions, then the land sea ice and the stratosphere and other sources. So here the right one shows the predictability. Here that we can see that this is somewhere like we can say that this is such a scale where the atmosphere influence of the atmosphere is almost diminishing, and the oceanic influence is not yet realized. So it is very challenging scale. And this is the timeline of development at IITM under the monsoon mission. So we started our journey in 2011, where we adopted the NSUP CFS model for developing the system. So initially we got the system at T126 resolution, and then we developed an ensemble prediction system. Then what we, from our experience, what we gained is that the CFS model is having a bias in the sea surface temperature. So what we thought that if we correct this bias and run the atmospheric component, maybe the skills may improve. So we just did that simple bean bias correction. So, and we used that the CFS forecasted SST, that is bias corrected, and then that is used to run the atmospheric component. So this was implemented in 2012. Then we moved to the higher resolution also, that is T382. And so every time we were seeing slight improvement in the skill. And in 2014, we thought of combining all these different versions, like different variants of the same model. And we developed the MME, multimodal ensemble. So, and then initially the system was run only for the monsoon season from mid-May to September end. And by analyzing the skill, we understood that the model is having a good skill. And there were requests from other, like basically the ministry wanted us to do the forecast for other seasons also. So we started the forecast for winter as well as other seasons. So the skill of the system was analyzed, and so in 2016, the first generation model, which is the multimodal ensemble, which Dr. Johnny already mentioned, which is now operational at IMD, that was transferred for this operational purposes. And so then in 2022, we developed the second generation ERP system and started generating the experimental forecast. So from May 2022 onwards. So in the meantime, we also had some publications where we demonstrated the prediction for onset, then from heavy rainfall events, then prediction for MJO, MISO, then heat waves, cold waves, and cyclogenesis also. So all these things were also developed during these years. So basically, the challenge in the subseasonal scale or the extended range comes from the basically these three things. That is the imperfect initialization, where we have the uncertainties in the observed meteorological fields. Then we have the resolution also playing a role, where the small scale physical processes are unresolved. Then basically the model error, where we have the approximate or incomplete treatment of key processes. So, so because of this, these factors, an ensemble prediction system needs to contain need to address all these uncertainties. So in the first generation system, where which is operational at IMD, so this system is having a reasonable skill in predicting the monsoonal rainfall up to 2 weeks. Even for temperature also we have seen. But the problem was that here we had different ensemble members, and also we had different variants of the at different resolutions, as Dr. Joni mentioned. So then we wanted to incorporate some aspect of this model uncertainty also. So in the second generation version, that was our motivation. So with this, what we did is that in CFS model which we got, it had different options of convection and microphysics. So we just thought of using all those and just make different combinations. So we had like that, and also we had a T382 resolution runs in the highest resolution. Then we thought of running it at T574 for the first 15 days, and then transitioning to T382. So so we have 6 combination of this physics, and each of them we ran for control plus 2 ensemble members, and we are using the initial conditions from NCMRW for the atmospheric ICs and INCOIS for this ocean ICs. So thus we run, and we just have 3 members for each physics, and then we have the physics multi-ensemble forecast having 18 ensemble members. So this is the setup of ERP-V2. So we just compared the skill of the monsoon rainfall for these 2 models. So earlier this similar plots were shown by Dr. Joni. So here we can see that the first version is having a useful skill only up to week 2. Week 3 the skill is comparatively less. In this version ERP-V2, the skill has been slightly improved, and as our chair mentioned, most of the S2S models give the forecast as week 3 plus 4. So that also we have seen. So that it is improving over some regions. But the most problem what we noticed is that in the week 4, the prediction is not good compared to the ERP-V1. So this is just for the different homogeneous regions. So see this is the anomaly correlation coefficient for different homogeneous regions. So here we can see that there is slight improvement, and also the probabilistic scale also over some regions it is improved, but in some regions it is slightly central India it is slightly reduced in the first week, but in the longer leads it is improving. So this is just the skill of the 2 models in predicting the monsoon intra-seasonal oscillations. So here this is the spread. So here basically as Dr. Akhilesh mentioned, the the ensemble systems tend to be under dispersive. So if the model is having a better spread, then it tries to overcome that under dispersiveness. So this version ERP-V2 is having because of the different combination of the physics and all, it is having a slightly better spread in the ERP-V2. And because of this, this is a sort of predictability, index of predictability you can say. So the RMSE spread variation, so ratio. So here it is much improved in the ERP-V2 in the initial up to 15 days or so. Then we have also seen the skill of the model in predicting the extreme temperatures. So we are talking about heat waves and other things. So here also we can see that compared to the ERP-V1, in the first 2 weeks, the skill has been considerably improved, and even week 3, it is slightly better over some homogeneous regions. So this is just the evolution of the forecast skill since the inception of National Monsoon Mission. So this is the red one with which we started in 2011, and for different weeks, week 1, week 2, week 3, and week 4, this is for the monsoon zone region, JJ's rainfall. So here the considerable improvement is seen in 2nd and 3rd week, even 4th week also, we have come a long way compared to the initial one. And this black bar just show the ECMW of skill. So, and as I mentioned in the initial slides, that we are also developing different forecast products. So this is both from ERP-V1 and V2. So this is for the monsoon intra-seasonal oscillation, that is MGO as well as MISO. Then for heat waves, then heavy rainfall, then cyclogenesis, then cold waves, and also the probabilistic forecast of rainfall. So all these we are disseminating through our IITM website. So as I mentioned, ERP V2, we started running experimentally in 2022. So we just checked the real-time performance of the model in 2022 and 2023. So as we know, the 2022 was like a La Nina year. So the monsoon was slightly above normal, and 2023 was a El Nino year, and the rainfall was slightly below normal. So we wanted to see this contrasting monsoon years, so how the model performed. So this is the week-wise skill of the JJS rainfall over different homogeneous regions, which I already showed in that earlier. So here we can see that up to 3 weeks, the model is having a pretty good skill. So in some regions, it is less. And here we can see that in the week 4, basically the central India and monsoon zone, the skill was very less. But over the other northeast and other things, it was performing better. But there is obviously year-to-year variability. And for 2023, the predictions were pretty good for almost all years. So we have tested these version for the 2 consecutive monsoon seasons. And this is for the week-wise verification also for the monsoon zone. So the purple line shows the observation, weekly average rainfall, and the bars are deterministic forecast, and the below shows the different probabilities. So here also we can see that the model has done a good job in both years. This is just, I have taken one active spell and a break spell for 2022 and 2023. So here we can see that it has given an indication of like rainfall will be above normal, below normal. So obviously the models, when we go for a longer lead, they have the spatial errors, but basically the usefulness of extended range prediction or subseasonal prediction is to get an outlook of if the monsoon is in a weak phase, when there will be an active, and if it is in a very active phase, when the break will be there. So in that regard, we have seen that more or less the model has done a good job in giving that outlook, that even if it is in a break phase, it gives an indication of the active phase when it is going to be. So similarly, vice versa. Then for heat waves also, we actually tried to modify the station based criteria used by IMD. So based on that, we have used the maximum temperatures basically, and the actual, then departure from normal, and also the climatological percentile values we have used for defining this criteria. And so one important thing I want to mention is that as we know, the models have biases in temperature. So we have used the bias corrected temperatures for in this criteria for giving the heat wave forecast. So this is just the skill of the model ERPV2 in predicting the heat waves. So here this left panel shows the SEDI score, that is asymmetric extremal dependency index. It is basically a deterministic skill score, but we have fixed the different probabilities of heat wave for and then done the skill score. And so here we can see that for different probabilities, like obviously with higher probabilities, the skill will be less. So even up to 3 weeks, the skill is good. That is what we have seen. Then this is just a snapshot of the heat wave event that happened in June 2023. So here from 4-week lead also, the models had indicated the heat wave conditions. This is the latest experimental forecast. This is based on the 26th April 2024 ICs. So this is just the rainfall. So this is the daily animation. So these forecasts are uploaded in our website. And this is the weekly average rainfall. So in the last week of May, means this 18 to 24 May, there is an indication of increased rainfall activity. But if we see the circulation pattern, the monsoonal flow is not like that. Like we cannot say that it is monsoon onset or something like that. Then this is the latest heat wave forecast. So here it is showing that during the mid-May and the later part, the central and other parts of the country is going to experience the heat wave conditions. So these are the take-home messages. So the prediction skill has improved a lot since its inception, and the second generation one is showing a good skill over its predecessor. And we are just analyzing the usefulness of the system in other sectoral applications, and meanwhile we are also developing the different products. So thank you. This is our website. So thank you.
Thank you for your presentation. Any comment or question?
Ma'am, what is the improvement in spatial resolution?
Spatial resolution. So that is what I was shown, like improvement in spatial means model resolution.
From subdivision level, below subdivision level.
Below subdivision, actually, district level, we have seen. The first week, the deterministic skill is very good. But as we know, even Dr. Mishra also showed that as we go to smaller spatial time scales, the skill of the model will be less. Because from a longer lead, it is difficult to say means spatially how the model performs. It is very difficult. So in a longer lead, we cannot expect. So week 1, it is very good, but not beyond that at a district level.
Any comment?
Susmita, very good presentation.
Thank
Just can you go for third or fourth slide initially, where you put the limitations?
Okay.
You listed some. Yeah. So I think what we are presenting, this is one simple comment only. I think this is not only for your model.
Yes, yes. Yeah, it is in general. Yeah. Yes, yes.
I don't. I feel that we don't have near solution.
Yeah. So we just wanted to see, like, as I told, basically we have seen is that extended range forecasts are very much sensitive to initial conditions.
Yeah, naturally. As
So,
you go.
yeah, as we go. So that's why in the third and fourth week, the prediction skill is less. So what we tried to do is like, just to address the uncertainty from this also. So both in initial condition also by increasing the ensemble members, and also to address the model like different physics. And what we have seen is that if we are going for because when we started with this multi-physics strategy, several comments were there that if which physics is doing better.
No, I'm not commenting. You are doing your job. Just I wanted that these are key problems for most of the models, even for startups. Or of course, once you go for a longer lead, these problems will get an effect.
Yeah.
Thank you.
Yeah.
Thank you for your presentation. All presentation is finished.
Okay. So let's thank Dr. Takemura from Japan Meteorological Agency for nicely chairing the session, even though we are running behind the time. And also I thank rapporteur of this session, Dr. Sabir Ali. So before going to tea, I just want to announce that next session chair will be Dr. Pulak Guha Thakurta, IMD. And next rapporteur will be Dr. Ashutosh Mishra. So I request all to quickly finish tea within 10-15 minutes and kindly join back for the next session. Thank you. I request next speakers to upload their presentation in the desktop.
कौन सा क्लास? हाँ जी पहले वाला पोस्ट करके फोल्डर है।
ओपन करके रखना है क्या?
ये पहले है।
ओपन करके रखना है क्या?
मिनिमाइज करके रखते हैं।
हाँ मैं ये भी मिनिमाइज करूँ ना?
इसको निकल दे उसको, ये निकाल दे रहा हूँ हट जाएगा ना। नहीं इसको रखो, अभी और कॉपी करके बात करना।
कौन आएगा अभी?
ये सेशन में नहीं?
दो ऑनलाइन है।
अच्छा ऑनलाइन है क्या?
हाँ
मिनिमाइज कर देते हो।
क्लोज नहीं कर रही हूँ लेकिन मिनिमाइज करने के लिए वो छुप गया है ना। हाँ।
So good afternoon all. I think we'll start our last session for today. It was basically a long day, and for this session, we have 4 presentations. So I would like to invite our session chair, Dr. Pulak, to chair this session, and the rapporteur is Dr. Ashutosh. Dr. Ashutosh, yeah, okay. So both are ready. Pulak sir, you can.
Thank you, Ansel. So in this session, we have actually directly some 3 presentations from the user sectors and one from Dr. Nochiketa, though it is related to hydrological sector. So we'll be happy to know how this our information, that is seasonal forecast, is used actual to the users. We request each of the speaker to limit the presentation 20 minutes. First speaker is Dr. Priya Nagaraj regarding role of SNT clusters in creating collaborative ecosystems.
Good evening, all of you. And before I begin with my talk, I would like to thank the organizers, especially our colleagues from IMD and IITM, for inviting me to represent science and technology clusters, especially Pune Knowledge Cluster at this forum. This is going to be a very different talk, I think, from what you've been hearing all day. I think it will also sort of highlight the importance of, as the chair of our panel mentioned, how data that is generated by all of you can be used for multiple applications, and how, as a cluster, we are privileged that we are able to bring various types of organizations together and see collective value for using data, human resources, infrastructure in the science and technology space. So I'm Dr. Priya Nagaraj, and I'm the CEO of Pune Knowledge Cluster. Pune Knowledge Cluster is established by the Office of the Principal Scientific Advisor to the Government of India, which I'll tell you a little bit more about. But before we speak about PKC, I would just like to give you a brief overview of cluster ecosystems. For a very long time, I think globally, there are a lot of examples of organized cluster ecosystems. Silicon Valley, the Boston cluster, hydrogen valleys, and I'm sure there are many in the climate space. And clusters are slightly more organized forms of ecosystems, and over a period of time, they get even more organized and become in some way very niche, serving certain sectors where collaborations are needed, and collaborations can be fostered either to raise economic growth, to mobilize funding, to make sure that you have increased representation at the policy level, etc. With the right kind of models, clusters can contribute significantly to the socioeconomic growth of a region and the country. And many of you have heard of these examples that I have listed here, which started more than 30, 40 years ago as very small clusters, which you see certainly today as regional clusters. If you look at what values clusters can provide, you can think of a cluster as a magnet. They are engines of economic growth. They connect various members and partners. They attract talent, capital, researchers, companies. They enable collaborative networks which are built around industries and research organizations. They can also enable solving industry-level challenges by academia and startups. And they also foster a lot of public-private partnerships and also help in the development of collaborative platforms. We are a very early, maybe at our infancy. We are about 3 years old, and I think about 3 years ago in India, there was a lot of talk around actually having organized cluster ecosystems, which are there solely for the purpose of building these kinds of networks and sort of helping these networks grow. For a very long time in the country, we've heard of industry academia engagements and how these can be fostered, how the impact of these engagements can be measured. But in order to put a form to it, a shape to it, give it an identity, and also recognize that this in itself is a job on its own, clusters were created. So there are clusters in 7 cities in India, all established by the Office of the PSA. Pune and Jodhpur is what we have in the western part of India, Bangalore and Hyderabad in the southern part, Bhubaneswar east, Chandigarh and Delhi in the northern part of India. Collectively, all of us work on the same mandate. Our mandate is how do we bring together academia, R&D institutions, industries of our surrounding regions, including our local governments, to share, to solve challenging problems of the region using innovative means, scientific knowledge, and engaging highly skilled human resources. So in many ways, we are an experiment to see if the region itself values what we do, supports what we do, and actually leads to socioeconomic growth of where we are. So what do we do as a cluster? PKC plays the role of the magnet or the glue. So what we do is we help in conceptualizing, initiating and facilitating multi-organizational science and technology projects. I'll give you examples of a few of that. And these are projects where the outcome actually benefits the city at a larger scale. So this gives a lot of opportunity for various types of stakeholders to come together, industry, academia, government, etc. And PKC is not a research organization and we don't intend to be. So the idea is we bring everyone together, we distill information from everyone, we enable them to put projects together, and either we collectively pitch that project for funding, or if there is a funding opportunity that is made available to us, then we invite our partners to come and actually put the proposal together. We also work very closely on the citizen engagement front. So a lot of the research that happens inside research institutions is actually taken by clusters and converted into knowledge that can be shared or being accessed by citizens. So we have citizen engagement platforms where citizens can analyze data or citizens can contribute to adding data which are of relevance to the city or science. We also help in identifying, validating, and piloting new technologies. So we work with startups, we work with industries, we work with a lot of foreign consulates where where technology exchange or transfer happens. And we also help or enable policy advocacy for our partners where we prepare vision documents, arrange stakeholder meetings, make them connect with the right kind of people, whether it is state or national, in order to influence policy. So basically the model or our ecosystem looks at academics, entrepreneurs, capital, government, and the corporates. And the idea is a successful cluster should be able to bring all of these together to add value. So when PKC was formed, there were a lot of stakeholder meetings held in Pune with the big industrialists, R&D organizations, our local governments, to understand what would be the themes that Pune would pick up to work on. And these are broad areas that we picked because we felt that there is enough strength in the city in terms of intellectual capability to work in these areas. We also got enough feedback from our local governments that these are areas of interest to them. And the industry of Pune was also relevant, or was also keen on contributing to these areas. So in the health space, we work predominantly in the public health space. Our work actually started during COVID because we were incepted during COVID, and we did a lot of interesting work by building this consortium of about 10 organizations in Pune: hospitals, pathology labs, R&D organizations, Pune Municipal Corporation, PCMC, and to some extent our state level engagements also, to build a very comprehensive disease surveillance program for the city. And since COVID, we have now expanded this program to vector-borne diseases as well as AMR. And we are also looking at the interface of animal diseases to human. That means how does animal disease transfer to humans currently. And as I said, this is entirely by a consortium that we've put together in Pune, and it was funded by Rockefeller Foundation and more recently the Bill and Melinda Gates Foundation. We also work very closely in the space of sustainability and environment, where we look at a bunch of activities which I will be elaborating on today. Unfortunately, in 20 minutes, I may not be able to cover everything that we do in all the areas, but I felt for this forum, what we do in the environment space would be most relevant. So I'll talk about that as we go along. In the mobility space, this was actually a very interesting space because we were approached by PMPML and PMC to say they will be expanding public transport opportunities in Pune in a big way. We already see that. We see adoption of EV, we see the metro being built, but Pune as a city does not have a history of taking public transport. How do you then get citizens to actually take public transport, number one. So we do what is called as nudge experiments. We design those experiments and we get a lot of information from citizens, which we pass on to our government stakeholders. We also help them in planning bus routes effectively. So in terms of what kind of people take what kind of routes and what kind of challenges they face, how technology can be used to improve those routes, etc. In the big data and AI space, actually big data AI is a technology. We use it across a lot of programs that we run, but we have a very special citizen engagement program or science program where we make scientific data available in a gamified way on a platform where citizens can analyze this data. So we have over 2,000 citizens on this platform today who analyze this data, and in the back end, this data actually is used to create AI algorithms, which researchers use in their research. So it's a very nice way to have large participation of people looking at large amounts of scientific data. I feel this might be very relevant to the work that you do because I understand you deal with a lot of big data. If you feel this is something that you would want to do, where you would want to involve citizens to look at data, and it's very easy to do, how do you convert that data into something that citizens can analyze? It's a great way to have participatory analysis of data. In capacity building, we conduct a lot of workshops, training programs where industries, R&D organizations come forward. PKC leverages the reach we have with universities, students, etc. We sort of matchmake both of these, and the experts from these institutions deliver courses, training programs, workshops, etc. And we also work at the school level very actively for STEM education. So in the environment space, we have certain forestry initiatives, water initiatives, and energy initiatives. And these have all come very organically based on our partners' requirements and needs, and in most cases our partners have really enabled help putting these projects together. We came up with the idea after many stakeholder meetings to have a sustainable water action plan for the Pune metropolitan region. This was advocated by our local as well as state governments. There is a water action plan that Maharashtra, the state of Maharashtra has, and Pune, of course, is detailed in that. But it sort of doesn't have an integration of a lot of data. So it doesn't look at data very holistically. And we have held over 7 stakeholder meetings so far to reach a point where we have now prepared a vision document on how this action plan should look like. And there are various projects that have stemmed out of this action plan, which we are currently pursuing. As you can see, it involves pretty much many of the organizations, including NGOs, our R&D organizations, etc., which have come forward to do this. There is a lot of opportunity to model, to create analytics platform, to be able to even gather ground level water data, which we use a lot of student interns to do. So it results in great internship projects. So if anybody is interested in contributing to this or understanding more about this, I'll be happy to share. How we do this is we work with various stakeholders. The idea is bringing them together. Just bringing them together sometimes can be very hard, just getting them onto one platform and having a very honest conversation on what kind of data is shareable, what is not, what can be done with the data, how accurate that data is. Are they willing to go that one step to verify this data or optimize tools by which this data is collected? And the idea is then can various organizations take up bits and pieces of this water action plan and actually convert them into projects. So one of the things that's come out of this is the smart city director approached us to understand what the cost of water can be in Pune, because one of the big problems with having a business model for water, which of course leads to a lot of other issues in the water space, is that your local governments spend X amount of money to give us water, but they probably don't even get like 0.2x back. Like it's loss, but loss is an understatement. So for them to understand what the cost of water can be, even if they don't decide to charge citizens for water, but what is that cost is something that they want to know. We work very closely with a very established economics institute in Pune called Gokhale Institute, which actually is helping us with putting this data together, which we will present to Smart City. Our work in water also attracted some international attention. So we have a partnership with Water Valley Denmark, which is an organization that caters to a lot of R&D and industry organizations based in Denmark. So they're a cluster like us, but they work with water. So we do a lot of joint work together in terms of introducing new technologies to our local industries here, exploring joint ventures in the water space, looking for solutions which we may not have currently. For example, non-revenue leaks. We lose about 40% of water when we transport water over long distances. So are there technologies which can monitor and fix these leaks? So we actually facilitate a lot of those discussions. We're also part of a very new kind of program called the Harit Bharat Fund. This is a land accelerator program which aims to transform or restore a large amount of land in Madhya Pradesh, Maharashtra and Chhattisgarh put together. And in many ways in this sector, this is a very new initiative. It's very organized. It involves about 5 to 6 organizations at the national level, including WRI, India Climate Collaborative, ourselves, as well as some organizations which are actually investing in these projects. What we have actually done is collectively raised pooled funding, which we are now giving off to NGOs and startups, which will actually work on various land parcels for restoration. The nice thing about this program is there is a lot of emphasis on data. So we will be collecting a lot of data through this program. And the idea is, can this data be used to further research and also understand problems and issues related to restoration? Water plays a very important role in this, as including temperature and other climate changes. We also work, as I said, at the citizen level and a lot of city level initiatives. We have a program called Connectree. This is a citizen engagement platform. And eventually this will become an AI-enabled platform. But the idea of this platform is that our local municipal bodies do a lot of plantations every year. Can these plantations be tracked on a platform through citizens? So we incentivize citizens to take pictures and upload platforms, and we incentivize organizations which are corporates or donors who can adopt saplings in a certain part of Pune and maintain them. Basically, it's a very small cost to make sure that they are guarded, they have sufficient protection, and they are maintained. And the citizen who decides to sort of engage with certain saplings actually keeps uploading data every few months, and they feel a sense of ownership towards the sapling because they get to monitor this over time. So we've been requested, at least after we've developed the POC, for about 2 lakh saplings to be onboarded on this platform in the coming years, which are plantations done by PMC and PCMC. But also we generate a lot of awareness about these plantations among citizens. So we conduct a lot of awareness drives, and this is an app through which people can, sort of onboard this data. So a lot of talks and meetings and, with ecologists and environmentalists sort of revolve around these. We also have a program through which we are trying to currently estimate a carbon sink or a carbon stock to understand what the carbon sequestration potential of the city can be, because this data is very important for various stakeholders when they carry out various activities, including our district level planning. So we have got data from the local governments for over maybe 5 years to look at the tree census data that they have collected. We're trying to see whether we can create models around this data, and future tree census can be automated so that you don't have to do a lot of this manually. We also have a program called Carbon Neutral Campus, through which our partners actually do carbon audits. These are informal audits that they do as internship projects with students, administrative staffs of campuses, where you yourself can participate and understand what your emissions look like. And we give you a report at the end of it saying this is how the data is to be analyzed. You can do this yourself. And these are small measures you can put into place to reduce emissions from your campus. And if you're ever thinking about activities to offset, these are the kind of activities that you can think about. The other program that we recently nucleated is the creation of a green hydrogen valley in the Pune region. This is in many ways a first of its kind program for the country. So the Department of Science and Technology announced a call last year, actually a year and a half ago, for setting up hydrogen valley platforms in the country, which is essentially a demonstration of everything from production to transport to storage to utilization of green hydrogen, which has not been done in India at scale before. And the idea is, how do you get to do this with a consortium of partners? Because this was not meant to be done only by R&D organizations or only by industries. So PKC nucleated this project for over a year. We mapped stakeholders in the city to understand who does what in the hydrogen supply chain. The map that you see on the left is essentially about 30 odd organizations doing various different things in this place in between Pune, Mumbai, Nashik. And we nucleated this project, and I'm happy to say that it's come through. So in the next 5 years, you will actually see a working hydrogen sort of ecosystem demonstrated in the Pune region for 2 application sectors. One is the specialty and fine chemical industries, and the other one is the transport sector, where buses will be piloted on the Mumbai-Pune highway using hydrogen as a fuel. In sort of a slightly different context, this is something we've been doing in the health space, and I wanted to highlight this because this is where we closely collaborate with IMD as well as IITM. Our work actually started with conducting or putting together a program for environmental surveillance of infectious diseases. This started with COVID because it started globally with COVID. So if you're aware, in Pune, or sorry, in India, we have a very robust wastewater surveillance mechanism for polio. So wastewater is constantly sampled at very regular frequencies to look for the poliovirus. And if there is virus detected, then there is an entire system that kicks in to understand how you can spread awareness, put vaccination procedures in place, etc. So the same thing was done for COVID, although there were a lot of unknowns, but I must say that because this was a global effort, there was a lot of sharing of information. Even within India, this was a 3-city effort: Pune, where PKC led it, Bangalore, and Hyderabad, and to some extent Delhi. And there was a lot of sharing of protocols, infrastructure, research, students, went across to actually build this entire system. And I'm happy to say that this system exists now for the city of Pune. We continue to monitor COVID. We also have a live dashboard, which you can see on our website, which actually tells you where we collect samples from various STPs and open drains. And every 2 weeks, you will actually see what the viral load looks like. What is interesting is this sort of brought together in many ways how people look at data, both from water in terms of water quality, but also water in terms of viral loads and from a health perspective. For COVID, we get a 3-week lead period where we detect the virus in wastewater before you start seeing it in the human population. And this 3-week window was very useful to our local stakeholders, our government stakeholders, to actually put actions in place. This is my last slide. I just wanted to say we're doing something similar for dengue. We have a dengue surveillance program in the city. We collaborate very closely with IITM and IMD for some of the predictive models that we wish to develop, because climate data is very useful in this. We also conduct a lot of on-ground training workshops for health workers to understand how they can detect vector-borne diseases or symptoms of vector-borne diseases on ground early. This is just a snapshot of some of our key highlights. We are a very frugally funded organization, but I'm very happy to say that we've actually mobilized about 65 crores for various partners that exist in our ecosystem. We have over 140 partners, including some international partners, and we have about 8 externally funded projects. This is a very small snapshot of some of the partners we work in the environment space. We're very grateful to the organizations that have supported us also from a funding perspective. And as you can see, it's a very nice mix of industry, academia, researchers, and government bodies. This is us. Please look us up at pkc.org.in. And I'm here till the end of today. So if you have any questions, please reach out. Thank you.
Any question? Thank you, madam, for very nice lecture. Actually, it will be happy if you have use that because IMD is already doing that vector-borne disease, but basically based on transmission window. And if we get some data that your surveillance data, in future we can implement whatever we are experimentally we are doing that for vector-borne disease for the Pune region.
Yes.
Thank you very much.
Thank you.
Our next speaker is Dr. Koilas on using forecast information to monitor crop health. Dr. Koilas.
Good evening to all. From my side and from organization, first of all, I express my sincere thanks to organizer to given this opportunity to share our work with this SISCOF forum. So just a few days back, I got a call from the sir. So you have to come here and you just share your work, what exactly the products you are utilizing with the stakeholders. So regarding this information, because we know in agriculture sector, we need the real-time information for planning seasonal forecast. Since morning, we are just looking, having the different kind of products. And the products, definitely it is essential in agriculture sector to take a decision. As seasonal forecast, last year, this year, we will have the different kind of planning. This year, we got the first long-range forecast release just 2 weeks back. So what was the opinion of the farmer? That this time the rainfall is more than the excess rainfall. So they are planning right now. Means the planning is started. That the forecast and it's because we have the different products. The seasonal forecast is playing very much role, dominantly role to decide the land holding, to decide the which crop they have to take. So similarly, subsequently we have the medium range weather forecast. Then we have the nowcasting, different products. So I'm just sharing our experience with the stakeholders, how they are implementing, how they are successfully overcoming the issues during the dry spell, drought, and they were even reverse condition during the excess rainfall condition, even in extremes also. So these are our some collaborators. Even from Space Application Center, we are getting some special products also to just capture the real-time changes in the agriculture field. So this is our domain. Our university is located at the Parbani. We have the jurisdiction of 8 districts in Marathwada, in Maharashtra state. So earlier we are doing this business for district-wise. Still, after the this Damu was closed, we are again having the same scale, that is the district-wise. So I'm just giving the constraint. What are the constraints at our locations? Just looking to the 8 districts, we have the constraint that we have the permanent dry space during the month of August. Either a very good rainfall year, you can take 19, 20, 21. So still we have the dry spell. Means we have developed some technologies how to overcome that particular period. So that's why I have shown how many days. It is almost 14 days of dry spell. Similarly, in case of the 2021, that was a good year as compared to the earlier 2023. Still, we have the different what we say either in the month of June or July, starting August and the end of the season, that is September. Still, we just am showing few examples again. Similarly, we have the dry spells over the different period and different location. Last year was we have the April month was May month was totally was a rainy season, and June was we are totally dry. So late onset was created problem to skip the short duration crops to the farmers. So in pulses particularly. So that kind of observations we have got. And farmers, they have not taken the crops because their sowing windows was completely finished. Then we have this forecast actual, how our forecast, that is our medium range forecast is just with the realized rainfall data. So it is showing us having the similar trend. It is following somewhere, it is having the gap in between in the month of the July or somewhere in the August. It is for a whole season. Similarly, we have just taken for a whole year because after this Kharif season, monsoon season, we have the Rabi season, summer season. So we are looking all the parameters, either rainfall or our temperatures also. Even we are just looking our PET, potentially transpiration products also from the SAC. We are computing and we are just looking NDVI also, because these are essential to monitor the health of the crop. How they are deficit, either in terms of biotic or abiotic stresses. So by looking, and we have some location specific studies. So this kind of database has given the idea or built up some confidence level among us to give formulate the agromet advisories. So this is again similar case with the minimum temperature, maximum temperature, and this was the distribution of this rainfall during the last 3 years. We can see same case, we have the almost either June or August is having the deficit for our Marathwada region. Then again, some forecast verification we have done for earlier years, 2020, because we should know the farmers, they have built up the confidence. Why? the forecast skill has been very much high. So this forecast skill and RMSE, by looking towards RMSE month-wise, we can say confidence level is good. That's why we are able to give the very good qualitative information to the farmer. Based on this kind of analysis, we are very much confident that this forecast is playing very good role while we are formulating. They are taking the action. We are formulating the what to do. So based on these products only. So this is for 2022 again. I will skip hurriedly. And this is for 22-20 day wise again. First day, second day, fourth day for this medium range. And this is the overall dry spells. So these are our constraints in our domain. Actually, we are facing this kind of spells, dry spells, particularly all 8 districts. And to tackle this this kind of problems, we need to come with some solution. Again, we have formulated this information to the public sector or the farmers by various channels of dissemination. This is a similar case. We have just organized some programs also during that periods, how to make or motivate the farmers. And yes, of course, some success stories of the farmers was published by the newspapers also. So this IMD, one by one I will go. So what exactly, this is the IBF. We are getting the, sorry, this is the just IBF we are issuing on the basis of the forecast, what alert they are issuing. So what kind of the damages are happening in the field on the basis of extreme of any, either it is the rainfall, temperature. So we are formulating and what exactly measures to be taken to the farmer to the overcome with respect to the type of our advisory. So we are formulating, depends on the variety of crops are available in the field, either orchards, vegetables or field crops, or even some poultry animal sectors also. So the implementation means if this information is once we have, we need to disseminate this information to our stakeholders. And implementation is most important. Farmer, they are implementing as per our forecast information. Either it is in the form of this nowcasting bulletin. Sometimes hailstorms are there, sometimes heat waves are there. So what measures to be taken, that we are formulating through this IBF. Same case with this, I am just quoting some few examples of this year only. So these are some micrometeorological observations we are taking to monitor different kinds of things, because we are taking point-based observation. We are looking to especially for 8 districts. So we should know what kind of the